Hello, everybody. Thank you very much for joining us here today. This is Paul Taubman with 9.connects. You are in the right place if you are here for our webinar on scripting. You know, in fact, you're here for a reason, and we know that topics of this nature are very important to you. Number one, that Altium Designer is a really large suite of tools. We totally get that. As a matter of fact, when I worked at Altium many years ago, I was just laughing about the fact that I only had to learn one tool, because prior to that, when I worked in the defense industry, I probably needed to know about 15 different tools. And yet, about 10 years later, here I'm still working on Altium Designer, and there's still many aspects of it to explore. It's a really large suite, and there's always that question to be asked: are we overlooking any capacity in Altium Designer that might help us to automate? And then there's also the desire to automate the design process as well. And the question has to be asked: you know, what are we trying to do to avoid turning our designers into administrators? So if someone's just sitting there and they're plucking away at an Excel sheet all day, that's taking really design talent and putting it into an administrative mode. So those are the things that we know are important to you. Is how do we make the design process move as easy as possible? How do we get the biggest bang out of the buck for our designers who should be designing and not doing things that are of an automated, that could be automated? So we here at 9.connects want to encourage you to ask us, and we're going to tell it to you like it is. And there's a lot of areas of Altium that I think there's questions about, like subversion, scripting, auto routing, FPGA, nanoboards, the Vault, or what's also known as the AVS and SPICE. Some of these we've already done in videos, we've talked about in past webinars. Some of them we haven't talked about, and probably for some good reason to it too. But if you're ever curious about any of these things or other aspects of Altium, feel free to contact us here at 9.connects. I'll be more than happy to kind of give you what they call the straight dope on it. So with that, welcome to our webinar. Just one last note: if you want to know a little bit more about us here at 9.connects, we have recently released a video. It's a 2-minute introduction. We've made it in such a way that hopefully it's just as entertaining as it is informative. If you go to 9.connects.com, you will immediately see that video. Just click on it and it will play away. So there it is. Now, today's topic is a primer to Altium Designer scripting. And this is kind of a loose agenda. We're going to talk about what it is and, in a sense, what it isn't as well. We're going to show how to run a script. We're going to talk about some of the basics of script coding, a couple of words of caution towards the end, and also where to find references and materials. If I was to go through this slowly and methodically, it would take me at least 2 work days for us to go through all of this here. I only got 1 hour to do this, so I'm going to try to get the key points about scripting to hopefully give you a good idea of what it is and what it isn't. All right, let's talk about purpose first and foremost. So why do we want to bother with scripting? Well, there's really 2 things that you can do with scripting. First and foremost, to automate what I'd call repetitive tasks, or things that would be very laborious if we had to do them by hand. And a great example of that is the logo creator, and I'll show you that example here in just a moment. Also, the ability to create reports as well, and I'll show you an example of that. By the way, just as a side note for administrative purposes here, what I'm going to be doing is I will be putting up the PowerPoint slides here, but I'm also going to be showing quite a bit in Altium Designer. The slides are really there just to make sure that I stay on focus, because I have a lot to talk about and in very little time to do it here. So we're going to jump over here to Altium Designer for a moment, and let's take a look at some of the scripts that they have available. Everything that you pretty much see on the screen, including the one I'm going to demonstrate here, they do come from Altium Designer. So Altium in the past, I think prior to Altium Designer 2010, used to provide these along with their software. And over time they removed it, and they may still make it available, but you've got to download it from their website. Okay, it's something that we cannot provide you, unfortunately, due to our relationship with Altium. However, you go onto their website and you look at them. Look onto their website. In fact, if you just basically type in Google like Delphi examples Altium or scripts example Altium, and you should be able to find that downloaded I think it's a zip folder, and you can download it at that point in time. That's where I got it from as well. And by the way, I'll talk about more references towards the end. So the example that we're looking at here is one of their older examples, but it works rather nicely, and it gives a really good overview of what scripting is all about. So the one that we're going to take a look at here for just a little bit is this one called the PCB Logo Creator. And this is a really great example of something that would be really laborious to do by hand. However, Altium can do this and manipulate the graphics so that you could actually bring a logo into Altium. This is one of the older programs. I think there's some better things that Altium now provides that make the logos look a little bit sharper, but it's certainly a really good example program of how you provide input into a script and how you get output out of the script as well. Now, just to take a step back, and I'll talk again more about this as we go along, if you're like me, you're probably what I'll call old school. And the old school is that we used to have a cursor prompt at the bottom left-hand corner, and we would type something like run something, or we would get a scan-C command that would say, hey, give me some input. We'd type it in, press return, and then the program would continue and things would scroll up the screen as you're going along. We don't have that luxury here in Altium Designer. So what you're going to find is that we have to provide input through other means, and one of the means that we do that is through what they call a form here. Now, here's an example of a project. So this is the PCB Logo Creator project. As I mentioned, it's an example that Altium provides us. It is a project that's called PRJSCR. It's a very easy project to open and start in terms of if you want to start a new project. It's a matter of going to File, New Project, and then making sure that you have Script Project clicked here. Most people will probably be in PCB Project. But if you click on Script Project and then you provide the rest of the name and you press OK, it's going to pretty much start a project in a very similar manner as if you're doing a PCB project. From there, you simply just add in your the type of files that you want associated with it. So before I go a little bit further into that, I just want to show you this one that already exists. So this is an example of a project that has really two files associated with it. The .pas really stands for Delphi. I think it's because in the past, Delphi was associated with Pascal. In fact, I think it got its roots from Pascal, and that's why you see the .pas over here. Why do we use Delphi? Well, that's because Altium was written in Delphi, and that's the same. So they used the Delphi scripting language or made it available. There are other scripting languages that you can use, but given that Altium was written in Delphi and given that their developers are primarily well-versed in Delphi and all their examples are in Delphi, or most of them are in Delphi, it's probably best that if you're going to do scripting, you probably want to do it in Delphi. So here's an example of two different files, one that does have a form and code and the other one which doesn't. You can just write simply code. However, there's going to be some limitations to that. The form is going to allow you to basically put input, or what we'll call conditions, in there, so that, or initial conditions in there, so that when it kicks off, it knows what to do here. And you can see this form here, and we'll definitely go into a little bit more detail. Now, if I want to run this, okay, how hard is it to run? It's actually rather easy to run it. It's just a matter of doing a file opening the project, and then once you've got that project open and it's in focus, it's really just a matter of hitting the play button over here, okay? And once I've done that, you'll see that the code has now responded because it's now opened a new session of a PCB doc, okay? And now it's brought up the form that we just saw, and now it's an active form. So I'm going to load an example file, and this again is all ones that Altium has provided over here. And I'm going to use this bitmap here. And the reason I'm going to use this is that this is a true black and white. So again, when they originally made this, you had to use a bitmap, and you also had to, it had to be a true black and white. It couldn't be a grayscale because the program was not going to be able to work with that. Okay. I know, as I said, subsequent things that they've added to Altium and other scripts that they've built allow this to be a little more eloquent, where you can really feed it other things other than just a straight black and white. But this is an older program, but it still does a great job to show and explain things here. So now that I've got this here, I'm going to let it convert. It's going to take a moment to do it. So going back to what I was talking about on the purposes, what we're doing over here is telling Altium to basically draw this for us. And once it's done over here, we're going to actually have a logo. I think you'll probably put it on, it's going to put it on the top layer because I didn't tell it to put it on the top overlay. But nevertheless, it's going to create this logo based off of opening up that file, this text file or this bitmap file, interpreting what those points are, and then putting in the primitives necessary to make this whole thing up. So I'm going to exit out of this here, and you can take a look at this. Okay? So that's one example of what you can do with Altium. We'll call it graphic manipulations. The second thing that you can do with it, and I've got another report, this thing called a report here, is textual reports. And actually, more often than not, a lot of aspects of automation in any type of process is really getting the text from one location to another. It's information that you need to be formatted in one way or another. So for example, a lot of people, when they look at the bill of materials, most people are content with the idea of the bill of materials just having columns of parameters, and then the rows just list each one of the components. However, there are people who are saying, well, no, actually, we'd actually prefer to have the component and then the row list all the parameters, and then we put the next component list everything as rows. So Altium itself doesn't do that, but that's another great example of what you could possibly do with the scripts here. Now, when just looking at this code really quickly, if you're familiar with, let's say, C++ or C, and I spent a lot of time in C and also BASIC and Fortran, I'm very familiar with the print statements. They don't really use print statements here. You can see that in this situation, they're using concatenations. They are using a lot of dots over here as well. What you're going to find with that is this has to do with objects and actions, and we will spend a little bit of time talking about these things here as we go about. But in this case over here, we're doing an action, which is to add something to this thing, which is an object called int_lib report, which is probably defined up here. In fact, it was. And you can see, as a matter of fact, it was defined as something called a T class, and we'll go into more detail about that here in a bit. And what you're also seeing is the literal string plus a concatenation of other things that are in here as well. So that gives you kind of a feel for the format. And I wish I could go into a lot more depth of the code. I'm going to show you a code here in a bit called tic-tac-toe. It's another one that comes from Altium Designer, and I commented the heebie-jeebies out of the whole thing. I mean, I put all these extra comments in there so I could understand what was going on with it, and I'll make that available to anybody who wants that thing afterwards so they can get a better feel for how the code and the constructs are working here. So there it is. We've got this example here. Now, in an example of this nature, because it's just strictly a code and has no form to it, it relies upon the initial condition of whatever window is open. Okay? And in this case over here, what I'm going to do is I'm going to click on this schematic doc they already have open, and I'm going to run it. Now notice that when I click on the schematic doc, I don't have a play button over here. So another way that I can run this is I can go into DXP, and I can go into Run Script. Okay? Now that I'm in this Run Script here, any of my files that are open over here are available to me. Okay? So it's just a matter of doing a file open, and as long as it's a script, it's going to be listed over here. And I have actually two different little programs I can run here. One's called model type. It's kind of a boring one. It just tells you what models might be associated with it. It might be useful for what you're trying to do. But just to show you something that's got a little more meat to it, this is basically an integrated library management report. It's basically saying these are all of the components and where they were located that you used on this particular schematic. So when I press OK, you'll notice that there was no form, and it just ran through it and just put it in the format that we set up in the code. So it gives you some idea as to what we've got over here in terms of purposes. Either we're trying to do some type of graphical manipulation, or we're trying to extract and get textual information put into a text form. And those, I think, are the two biggest things that you can do with it. All right, let me continue here from our slide. Okay. And so what are the languages that are supported in Altium Designer? As I mentioned, Delphi is the biggest one. If you're used to these other ones, like especially Enable Base, actually it's JavaScript or Visual Basic, you can certainly use those as well. Just keep in mind there won't be as many examples to go off of on those. There's also one called Enable Basic, which I got to be perfectly honest with you, I'm not very familiar with that. I assume it's just like basic programming. And then there is one called called TCL, or better known as Tickle. This used to be very popular, I'd say primarily in the 1980s and 1990s with those who were doing a lot of work in Unix, because it was a very good like one-line scripting type of capability. You could do a lot of things with it. It's very, very powerful, but it tends to be kept towards the folks who are doing Unix. But nevertheless, Altium can handle that as well. Now, as I mentioned before, a lot of times we got to use something that's called a form, and that's how we put our initial conditions into our program so that it can run off and do what it needs to do. Well, there's only 3 of those 5 languages can do that, either Delphi, VB, or JavaScript. And if I jump out of here for just a moment and I go into, so we've got our project over here, I'll make that that's the one I'm going to try to add it to here. I'm going to do the File, New, and I go into Script Files, you'll see what things we have available. So you'll notice that for script, that also means Delphi. Either I have a unit or I have a form, same thing with the script. What they mean by unit is just code only, as opposed to the form where I'll get both the opportunity to do both the code and the form there, and so on and so forth. Notice that TCL script and Enable Basic script do not have forms associated with them. So these would be things that you would write strictly to run against some type of thing that's already on the screen to extract out information and then get some textual information out of it. Okay, so that's how you'd add those. If I click on this here, in fact, we'll put a form in there. Okay, let's see where I put it. Sometimes because it's not the one that's in focus, I'll drag it down over here. So if I do a form here, I can put the code in here, and then I automatically get a form over here as well. I'll just talk about this briefly, and then I'm going to go into a little bit more about forms here in a couple of minutes. To do a form is a little bit different than using a schematic editor or a PCB editor. You actually have to have two of the panels up for that. One of them is the object inspector, which shows you the properties of whatever it's focused on. So right now it's focused on Form 2, and then it also shows you what's called properties and then the events. I mean, what actions can you take on this particular form? Okay? And actually, quite frankly, you really don't take too many actions on the form itself. You usually take it on a button, or you take it on a radial, or you put it in a text box. And we'll see a really good example of that here as we go along. The tool palette are all the different things that you can add on to this form over here. If you're familiar with Delphi, by the way, this looks remarkably similar to some of the Delphi programs out there if you're trying to build programs just simply out of Delphi. So I have a suspicion that a lot of this was taken from an existing code that Altium dropped in. And it would make sense to do so, because if we understand these things called client servers and the way Altium set up the entire architecture of Altium Designer, it would make sense that they could just drop something in that was already there. So if it looks remarkably similar to some other programs, that doesn't surprise me in the least, because Altium has the ability to do such a thing in their architecture. So that's what we've got over here. The only difference is that when you click on one of these features and you drop it in, then you click once and it'll drop it in. So it's a little bit different from the way we'd operate on primitives and the schematic and the PCB side. Also, you don't really double-click on it to get to its objects. Once you've got something on there, you click once on it to highlight it, and then it becomes, all of its information really becomes available through the object inspector at that point. Okay. So as I said, we'll spend a little bit more time on that here in just a moment. So let me jump back over here to our current slide. We talked about this for a little bit, but it's good to understand the concept of a project. You don't have to do a script in a project. However, in the past, if you're going to do anything with a form, you should have had done in a project. But you're going to see with the tic-tac-toe game, that was always a free document, so it seems to work without a project. But if you're going to split the program into 2 or more files, and that's very common for large files or people who do a lot of programming, then you definitely need to put that into a project. And then, of course, the other thing, too, is what we'll call preventing of global variables. What happens here, and I'll jump back over here to Altium and go to our projects, is that if I've got a bunch of free documents over here and my coding isn't all that good, what happens after is that when I run these things, I can be leaving residual information in the background. And if those variable names are the same for each one of these things, what I ran in one could actually impact another script when I execute upon it as well. So one of the nice things about doing a script in a project is that it confines all the variables to that project and that project only. Nothing from the outside can influence it, and nothing within the project can influence the outside. Whereas in the free docs, well, it's kind of free range, and it can be the Wild West if you're not really careful about your variable names, and B, your initialization of variables as you're running these projects. So just be aware of that. Okay, let's jump on back over here. All right, now the limitations. One of the things is a lot of people look at the scripting thinking that they can somehow improve Altium by adding maybe new primitives, or what we consider to be primitives. And there are actually some pretty big limitations to this. First and foremost, you can't create new primitives. And then secondly, within the primitives themselves, you can't add, remove, or modify properties. And I'll give you a really good example of one that people ask for quite often. So let me jump back over to our LCD example. A lot of people look at the power port, right? This is a very special primitive in Altium Designer. If we go place, and we will see that we've got our power port up over here. And when they look at this over here, they're a little frustrated because they may not have the symbol that they prefer to have. And they would even like to have it in such a way that, let's say, hey, if I draw this in the schematic editor, let's say the schematic library editor, I want to be able to somehow associate it either to this one, this power port primitive itself, or create another power port primitive altogether that allows me to use whatever symbols I create in the symbol library editor. Well, the scripting, number one, will not allow you to create a brand new primitive. That's number one. And number two, the scripting will not allow you to modify any of the existing properties of these primitives. So like the style is actually a property of this power port here. It's not going to allow you to modify the enumerated list. So just keep those things in mind, because really you're limited to, hey, this is what we've got here on the menu. You got to work with what we got over here. No, you cannot change or custom order something within the within the menu that Altium is providing you here. Okay. So just want to bring that to your attention if you're thinking you had grandiose plans. I know that if there's really big things that you want to do with it, then Altium, I know they sell an SDK, which is called the Software Developers Kit, but even then I don't think they give you that much reach into their basic primitives at that point in time. Now this kind of gets really important here. As I mentioned early on, I'll mention again, we don't have that neat little cursor prompt at the bottom left-hand corner of our screen. So we got to figure out ways of providing input and output to our, basically to our files here. So when it comes to the input, there's 4 different ways that I could think of to do it. First and foremost, you could do it in the code itself, which is kind of kludgy, but you can do it. And just to give you an example of that, I was playing around with this. It's actually a very simple little program, and I like it because it just showed me very quickly how I could put together a program in Altium Designer. So here it is. I just initialized an I and j, call them integers, and then I took I and I made it a value. Now notice it's got a $sign in front of it. For those people who are not, let's say, that coding savvy, that means it's in hexadecimal format. And then there's a j over here, and it's also in hexadecimal format as well. And what I'm doing here is I'm really taking these two here, and in a sense I'm adding them together. In fact, I'm doing an AND operation, a logical AND operation to both I and j. I'm having it convert to a string, and I'm going to show a message. So in this particular example, I'm not using a form. I'm not relying on any information in any of the other windows. I'm actually manipulating the inputs through the program itself. And if I was to run this, okay, and I click on, I can do the run through the menu here, or I can do the button. Okay, I get the number 10, and that would be correct because what I'm doing over here is I'm effectively ANDing all ones, which is j, to a, which is a hexadecimal version of 10. It's a decimal version of 10, and this is showing me the decimal version of it. So if I wanted to play with this all day, I would just go in here, make a change, save it, and then keep rerunning it, and I would get an answer. You can do that. That works rather nicely when you're trying to debug code, but obviously it's not very eloquent when you need to do something of a larger scale. So let's go back over here to our current slide here. All right, jump there. Let's see. So initial conditions from the screens are parameters. That's another way we can do that. Actually, I jumped here. Let's go to the form. We saw examples of the form, just like when we did the logo creator. We had a form that allowed us to take information or put information in there so it knew which layer to put it into, or the thickness of a line if we wanted to put that in there. If we did another, there's another example like a board outline, where if you call it the board outline, it'll say what layer are you on and how thick do you want the line to be when I draw this outline. Okay, so that's an example of some forms, and we're going to see the tic-tac-toe one here in a little bit. We also have initial conditions of the screen, or the parameters. This is what you'd primarily get from, we saw this again with the report that we saw. So we opened up the schematic report, or we opened up the schematic, and then we ran the library report on it. And so it was able to do that because it took the initial conditions of the screen. It says, oh, okay, I'm working in this editor over here. I can get access to the parameters of that editor, and then I can put that out into a text. And then the last thing we can also do too is we can, if we had an outside text file, and this again was what we saw with the logo creator, is that we took a file, which effectively is the bitmap, and we were able to open that and have Altium read it in, and then do something with it, like convert it into lines, which in turn turned it into a logo. Now on the output side of things, well, how do we get some outputs out of this? Well, we can see the results on the screen like we saw with the logo. We can get results written to a text file, which is what we saw when we ran that library report. And we can also see the results placed back on the form, which is what I'm going to show you in the tic-tac-toe game here in just a moment. And that takes me to this point of forms. And I've alluded to this quite a few times, but I think we want to spend a little more time onto it, because if you're going to do something in Altium, more than likely you're going to need to do something through a form. So obviously they're there to provide input, but they are also graphical features for helping you set up the program itself. And you'll see these examples as we go along. Now we have to understand that when we're making a form, we are dealing with something called objects. And I'll talk more about objects a little bit later on, because we're really dealing with something called object-oriented programming. But we are using something called objects. And in object-oriented programming, we have 3 things. We have properties, we have events, and we have actions, or what we can call commands to the program. So let's take a look at this tic-tac-toe game here for just a moment. This is, again, one that Altium has provided. What I've done with it is I've taken the code and I have put in all these additional comments to it so that I can understand line by line what's going on with it. And also to really also understand what is, what I'll say, belongs to Altium and what belongs to the Delphi scripting language too. So there's some of these commands that they use that even, let's put it this way, every coder has their way of doing things, and the way they did things in this, I don't think I would have necessarily done the same thing. So a lot of times I had to look and understand what the coder was trying to get it to do, and many times I had to remind myself that, hey, this code does work, so obviously what this individual did is correct. I just got to understand how that particular code was working. Okay, let's jump back over here to the form for just a moment. So in this form here, we've got all these different labels. Okay, and I'm going to click on one of these labels over here, and I'm going to jump back to the Object Inspector, and I'm going to go back to the properties. So let's notice a couple of things here in the Object Inspector. First and foremost, at the top left corner, we have not only the name, it's also the caption too, but there's actually a name over here as well. We have the name, and we also have its object type. And as I mentioned earlier, an object, you can think of an object as like a primitive. It's not something that we can change. Okay, no, it's nothing we can change at all in terms of its properties or its events or its actions. It's already been predefined to us. Okay, so we've got the properties here, and we can make these changes to them all day long. We can center things, we can change their fonts, we can change their colors. Properties are those things that just give you really a physical appearance to them. And then there's also an event over here as well. So notice that over here on this particular cell, it says label cell 0 click. And we're going to see this here a little bit more in just a moment. Keep that in mind. But also notice if I click on label cell 4, okay, the name changed over here, and this event also happens to have the same thing. So if I click on something different over here, the events are going to change. So even though, I'm going to go back to cell 3, even though cell 3, cell 4 look exactly the same, I'm actually looking at cell 4 now because I'm clicked on it. If I go to cell 8, I'm clicked on it. Notice that they all have the same thing, LBLC0 click. Because these all kind of work in the same way in terms of what action needs to be taken when you're doing something. And that's really what's happening with the form over here, is that this form isn't going to do something until you respond to it. So if you open up this form and then you, let's say you go on vacation for 2 weeks and you forget to close Altium Designer and you happen to have this form left, it's just going to sit there waiting till you make another command with it, assuming the power wasn't turned off or the administrators in somehow, some way, some form pull away your license, right? But if it was just sitting there the whole time, this form is not going to respond until you click on it. And then when you click on it, that creates an event, and then the event forces the code to respond, which is called an action. Okay, and that's what we're going to see over here in just a moment. So just keep this in mind, LBLC0 click. When we go over to the form side, the code side of this, and we'll go to the very top here, we'll notice that every single one of these things that we have drawn in the form is also listed over here, whether it's the radial group or our scoreboard or our buttons or our label. They are all defined over here. But more importantly, when we define these things that we're going to use, we're also got procedures for it. So you can see over here that there's this procedure. If I do a Control F on this here, and I'm going to say, okay, I'm going to go forward, I'm going to press OK. It does find it. If I do an F3, it's going to jump me to the next one. So this is just calling out the procedure, and it notices a T-sender object. I'll talk about that in just a minute. But this procedure over here is just like a function. The only difference between a function and a procedure in scripting is that a function returns a value where a procedure does not. At least it doesn't return it back to the program. It may show something on the screen. So when I click on F3 over here, you can see that now if someone was to click on that, and that's what we see over here is the event, so it will detect that click, and it'll say, well, okay, who's the sender? Who sent that? Well, if we clicked on cell 8, then whatever the information is on cell 8 is going to get sent through this procedure over here. And it's going to do things like check to make sure that the game is not over. It's going to make sure that something's not already in it. And then it's going to check other things. It's also going to put an X or an O in it, depending on whose turn it is. And it's going to just keep things moving along here. So just to show you how this all kind of works out, let's actually run the program right now. In fact, I just need to hit the run button and it'll come up. And let me pull this up from my other screen here. Okay, so here's the tic-tac-toe game. Now granted, we didn't draw any lines across this, and it's one of the things I'm going to work on there. But remember, those are objects, and if those are objects, there are things I've got to add to the code as well. So everything counts when we're doing these type of forms. So to start the game, it's a matter of us clicking away. All right, so I'll just throw some stuff over here, and as we're going along, all right, if it wins, it knows that it wins because it will actually do an evaluation check. So when we click on this, we kick off this event, and in this event over here, eventually it's not only going to put an X in there, it's also going to do a check to win to see if the game is won. Now, it also has some smarts as well, too. So let's do a new game over here. And by the way, notice when I click new game, it was basically to set all the label. What they did was these labels over here are just showing the value X or 0. It basically sends them back to blank. So when I start this over here, let's say I put an X here and I want to put an O on this. Well, it knows because I clicked on this particular label that, hey, you already got something over here, so I'm not going to overwrite it. So there was some smarts that were put into this. If I want to reset the game, let's say a new game, it's going to prompt me to make sure that I really want to do that before it clears it out. So these little things that they put in have some smarts. If there's a draw to it, let's see if I can do a draw real quick. So if we do this, he'll block him. This is one that I think my kids and I always seem to get into. And it'll show that, oh, it's a draw, right? So it's smart enough to evaluate a draw as well. And these are the kind of things that are going on, but they're all event-driven. Every time we click on something, it's going to change it up. So if I do a new game, O would go first in this case, and so on and so forth. If I press exit, that's what it's going to do. So when we look at the code here at the bottom, especially the bottom ones, by the way, there's always one that's called show modal. And this is basically say, hey, bring up the form. So this almost always, actually I think pretty much always has to be shown when you're doing these type of things. But you'll also see that when we click the button over here, so this is another procedure that was listed above. So if we click the button over here, it's going to basically do the close feature. Or if we click on the reset score one over here, it's going to take care of some stuff for us. It's going to prompt us with that message, right? So we saw that message dialog, and then it's going to ask us whether or not we want to actually press OK. If we press OK, we do one thing. If we press 0, we do another thing. Okay. So if we press cancel, we just exit out of the procedure. So hopefully you're kind of getting a feel for this. Again, it's event-driven, which is very different from what I think a lot of us have grown up with, where we think of a main and we call these functions as we're going, and then there's a logical process that goes along with it. Really, this is just being done as buttons are being pressed. Excuse me. As a matter of fact, there really isn't a main in here, which when I first was looking at this, I was struggling with because I'm always looking for the main. When you're doing these things here, there is a variable list. So then that, to me, almost seems like it would be the start of that. But in the end, it's just a bunch of procedures. And again, those procedures are called by the events that we put in to whatever the button or feature we put into the form, okay, or the object, if we want to use the proper name for it. All right, let me jump back over here to our slides. So we've talked about the forms here. Now, in order to do things in Altium Designer, we've got to understand how the architecture is set up. Okay? And there's two ways to interface with a program in Altium Designer. 99.999% of the time, you're using the graphical user interface. And that's everything I've been showing you and doing so far in Altium Designer, with the exception of actually running those programs. I'm actually using the GUI interface to do it. When I click on something and drag it, I'm using the GUI interface. If I'm going into the menus and I'm clicking on something, I'm using the GUI interface. Pretty much everything we do is through the GUI interface. The other way that we can do it is we can use what's called the APIs, the application programming interfaces, where basically there are portals into the code, and we can send commands in and do things, and in turn we'll get responses back out. Okay? And the only way we can access this is through the program. We wouldn't access this through a GUI interface. This is the actual client-server architecture in Altium Designer, so we are the clients. We ourselves cannot do any of this stuff over here. We just simply are given the ability to click on hotkeys or go and click into menus and to basically tell them which commands we want to use. That gets all sent over to something called the Workspace Manager, and it's also known as the DXP platform. As a matter of fact, before Altium Designer became Altium Designer, it was called the Designer Explorer platform. And the idea behind this was to get away from tool chains, where you'd have this one server, and we'll talk about servers here in just a moment, and that this server over here would manage all the other servers. Now, if you look really closely at these, we would probably call these editors, but the fact of the matter is that these are not just the editors themselves, they also contain the primitives that are specific to the schematic server, or the primitives to the PCB server, excuse me, and so on and so forth. Like, for example, if I had a VIA primitive, I would not see that in the schematic server. I would see that in the PCB server. Also, if you've ever noticed that, I'll just jump out here to take a look at this, you'll notice that all of these menu items over here and all these tile things that I can click on for shortcuts are specific to this type of editor. Right now, I'm in a scripting editor. However, if I was to go back over here to our LCD schematic, All right, this all got changed out. All of these things got changed out. Notice that the tool palette's no longer there. Notice that the object inspector is no longer there. In turn, the schematic filter has been replaced with it. All of these menus have been changed. All these icons have been changed. That's the Workspace Manager at work. So when we click on that, the Workspace Manager recognized that we were no longer in that one server and that we are switching over to the other server. Okay? And that's what it does. And there's a lot of power behind that, believe it or not. For us, we don't really see it. But from an architectural and from a program standpoint, it is actually very powerful. One of the things that they can do very easily, and we just saw this very recently in Altium Designer 16, is that they can drop another server in here as they are expanding the tool. So in Altium Designer 16, they introduced something called the Draftsman tool. Okay, that's not a part of any of these other servers here. It's really its own standalone server. Okay. And it's easy to do because of the way they set up this architecture, where in, let's say, classical programming, the way I was taught, you create all these functions, and you would have a main, and you'd go through these things, and if you had to make a change to it, you would have to go through the main and make all these modifications to address this new functionality, which, when you've got thousands, if not millions of lines of code, is next to impossible to do. That's why so many people usually abandon code, and they start it again, because it's actually faster because of the fact that the architecture was not set up appropriately. Now, this is just another way of looking at the client-server architecture. We ourselves are the client. The server, like the Workspace Manager, is really just this piece of code. Now, a lot of us think of servers as these things, these boxes sitting in these cooled rooms, and they're acting like, acting like servers, right? But the fact of the matter is that really a server is just a program, and we, the clients, are sending things to the server. The server is doing whatever is necessary to process it, and find data, process things, move things, so on and so forth, and then sending it back response to us, all right? Now, an API has the exact same concept, and as a matter of fact, there's a really great little video out there. It came from MuleSoft Videos. It's a company, we here at 9.Connects do not have an affiliation with them, but it was a really great little video, because it reminds me a lot of the video that we put together for our introduction, which I mentioned at the beginning of our webinar here today. But also, in addition to that, it does a really good job explaining both the concept of APIs, and even though they didn't mean it to do this, it also explains the concept of client servers as well. Now, where APIs, or what's a really good realistic analogy of an API? Think of Google. And the fact of the matter is, everybody's familiar with Google Maps. And you may go onto some website that has no relationship to Google whatsoever. But when you go onto that website, let's say it's like, let's say maybe even like hotels.com, and I don't know if they specifically use this, but I think they would. When you go there, you want to see a map of the hotels. Well, hotels.com is not going to invest in the same amount of time and energy into a mapping system that Google's already done, because Google's already made something like an API where in their code at hotels.com, and again, I'm assuming they've used this over here, but I'm just going to say, use this as an example. They're making possibly a call out from their code into the Google API that says, hey, show me these regions and these geographical locations of latitude, longitude, and then send it back to me along with, this is the type of map that I want as well. So as a result, they can take this information, push it over to Google. Google's app or API responds to it and sends it back, and now you get to see the map on that particular website. And of course, Google gets a little bit of a sweet deal out of this too. Some of these apps you do have to, pardon me, I shouldn't call them apps, APIs, you do have to pay for, but in addition to that, there's advertising that comes along with that as well. And Google gets its advertising dollars from people using their APIs, because they can push along some of their advertisements when that information is getting passed back. So that's the way to take a look at it. So APIs have become very, very popular on the web, but we can use the same thing too in programs, and even Microsoft Office has APIs as well. Most programs these days, if you want any type of level of automation and to allow other programs in there to do things, will allow you access to the API. But here's a really great analogy to understand that. If you go to a restaurant, the last thing that you are going to do in a restaurant is to go straight into the kitchen and cook your own dinner. Right? Either they're going to kick you out or offer you a job, one of the two. But in all seriousness, we don't go to a restaurant in order for us to cook our own food. We sit at a table and we get a menu. Okay? And then what's really that menu? Well, in our analogy, it's all the command sets that we have available to us and the parameters we would need to provide in order for that command to work. Now, we ourselves don't take the menu and run to the kitchen and tell them what to do. We have something that's called a waiter, which, if we're keeping with our analogy here, is really the interface. And we tell the waiter, or our interface, what we want. And the interface goes to the server, or in this case the API, or in our case the kitchen, tells the kitchen staff what needs to be done, right? And then after it gets processed, the waiter comes back with what we asked for. So just a really, really great example of what an API is, and also really the client-server setup as well. So take a look at that video. It's really, really great. Now, I've kind of spoke about a couple of these things, but just to kind of remind you of them, what makes it so powerful for Altium to use a client-server architecture? Like, for example, if they want to add in new servers. Now, they added the Draftsman tool recently. A couple of years ago, they also opened another, or created another one that they dropped in called Open Bus Schematic. If you're not doing anything with FPGAs, you probably haven't seen it, but that was another example of them just putting a brand new server into Altium Designer to address open bus issues, or design, really. It's not issues, it's really to do design. It allows Altium to operate in one window, so Altium is not what you'd call a tool chain. And back in the 1990s, that was really common to have these things like tool chains. You'd have a company that would specialize in one particular software product, like they would have a schematic editor, and then they may come out with another product that would be the PCB editor, and they would sit as separate programs on your computer, and then you would have to export from one and import into the other, and it was a bit of a hassle. And most of the people, when they first bought Altium, one of the things they loved about it is that they didn't have to deal with that import-export of the net list, for example, and that Altium kept their net list so tightly coupled that you didn't have really any problems with that, which tended to be a big problem when you had separate tool chains. And putting a wrapper around a tool chain, that's what people did quite a bit. I won't blame on, there's a couple of major companies that used to do that all the time, and I won't mention them, but they would just basically take these individual disparate programs, and then they would put a big wrapper around them, and then somehow that wrapper was supposed to make all these things talk to each other. But unless you, it was never designed to really do that, and there would be exceptions and issues, and it never really worked 100% of the time. So what Altium said is, let's put everything on this platform, and let's make sure that the workspace manager knows how to talk to these things. And they also said, let's do this in object-oriented programming, which I'll talk about again here in a little more detail in just a moment. Allows a lot for data sharing, which I just mentioned, so there's no need for us to ever go out of Altium to import or export things. Now, granted, if you're going outside of Altium to another tool to import and export, then obviously you got to do that. But within Altium, notice how you never leave the window. I don't know if you ever really realized that, but when you're working in Altium Designer here, I just jump from one window to another. The workspace manager handles that for me. I never have to minimize this and go click on something else. I never have to export something and then go to another server within Altium Designer and have to import it in myself. You don't have to do that. The workspace manager handles all that for us, and I think we tend to forget. It's really so obvious and so easy, we just forget it's even there, right? So it's not that obvious because it's so obvious. So let's go back over here and take a look at this again. All right. And lastly, it also allows for some of the common GUI interfaces, which you can see here. So you'll notice that there's commonality between tool functions. Now, that's not to say that the Workspace Manager has tool functions which the other ones don't have, but like, for example, with the zooming, what you do in the schematic server for zooming, most of that code was probably copied over to the PCB side for zooming as well. In fact, they probably added a few extra features on the PCB side that the schematic doesn't have. But and you know that this is not a part of the Workspace Manager, for example. Let me see if I can jump up over here. Because if you think of, was it Camtastic, I think that's the tool that they also have in here. The architecture allowed them to drop that in here, right? They're able to bolt in a tool that has really nothing to do with the style or flavor that the rest of Altium Designer has over here. But in order to zoom and pan and do the other things in that one, it kind of takes a separate set of commands to do that. So they're all kept in that particular server. All right, let's go on over here. So let's talk about OOPS, or better known as object-oriented programming. And this is the basis for all of Altium Designer's primitives, or what we consider to be a primitive, like a power port or a node, like a junction node or a wire component. These are all things that we call primitives, but really in programming, they're not called primitives, they're called objects. Okay? In the classic programming that most of us have grown up with, including myself, and pretty much the 5 languages I've learned over the last 30 years all do the same thing. We declare variables, we declare functions, we create a main, and then we manipulate all the variables and the functions through the main. But as I mentioned and alluded to earlier, that's problematic. Okay? And the reason why it's problematic is that when you've got a lot of people working on a code and you've got thousands of lines of code, when you introduce something new to it, it just takes a tremendous effort to try to make the code work to whatever new thing that you provided to it. As a matter of fact, back in the 1980s, there's a book I was reading. It's from 1986 about object-oriented programming, where the author was trying to encourage people to start contemplating this concept of object-oriented programming. That the stats that he had back then were just amazing. Everybody wanted to go to computers back in the 1980s, especially the insurance industry, which has a ton of forms. And yet it was really difficult for them to do that because of using this classic programming structure that I'm mentioning over here. So what he was doing was trying to do a call to arms saying, move to object-oriented programming. So what is object-oriented programming? It is basically taking, instead of having the variables sit separately and their functions sit separately, you look at something from what it is and what it can do. So for example, if we take a car, or any other object for that matter, they have properties, which we'll call data, like the color, the size of the engine, the type of seats, the miles per gallon, so on and so forth. And then there's also actions, which are the functionality of the car. Like we expect the car to be able to go reverse, or to go forward, or to stop, or to play the radio, and so on and so forth. So there's properties and actions, and the idea behind the object is you roll all this up into something that's called a class. Okay, you take this and you present this as one, rather than having these things be separated out as a bunch of variables and as a bunch of functions. Okay. And by doing that over here, you really start to make it easier. So if you drop in something new into the system, by the way, let's say you create a new class of it, it doesn't interrupt all the other code. The other code will work just fine. Now it's just a matter of making this new object that you've created work with the existing code, in the sense like, oh, well, if this other object is supposed to work with this, then let's make it now talk with this over here. But it won't interrupt everything else, where in the past, if you had that, it would really cause a lot of consternation and a lot of code changes to do that. Now, one thing that I found with objects, and this is little bit confusing, is that this term called objects and this term called class are thrown around quite a bit, but there's actually a meaning or difference between them. A class is what you'd call a template of properties and methods. Okay. For example, if I wanted to create a car class, and I can't do an Altium, but let's say I was writing some coding, and I say I'm going to create a class, and this class is going to be called car. And then I could basically say, okay, my properties are going to be the ones I've listed over here. I want, as a part of my properties of my class car, the color, the size of the engine, the type of seats, miles per gallon. But then I would also have my methods as well, which would be my actions. Okay, so what happens when I need to go reverse, or if I need to go forward, I need to stop, or and so on and so forth. And that's what I would define. But then the object is the thing itself. So let's say, for instance, I created this class called car. And now later on in my program, I want to have something that's very specific to a car. So maybe I'll have an object that's called Toyota, and then I will have Toyota of class car, meaning that the Toyota will take on all of those properties and methods that have been defined in class car. Now, granted, the values will change, and they'll be specific to my object that's now known as Toyota, right? But it's using the class as the template for all the information. And maybe further down I have one for Ferrari. The same thing. It will be of class car, but all of its properties will be based off of this template that I've got, and all the values are going to be those values that are specific to a Ferrari. Okay. If I jump back over here very quickly to what we've been doing, let's go back to our tic-tac-toe game here for a moment. That's exactly what you're seeing over here. So if I zoom back up to this here, okay, these are all things that are classes, right? In fact, we call up this class called T-form, and the T-label is also part of that as well. So the T-labels, well, what are the properties and events? If we go back to the object inspector, we see these properties, right? These are the properties that are all specific to a T-label. By the way, I cannot add or subtract anything to this. Again, I cannot change the classes in Altium Designer. I can only change the values of those properties they have. Or the same thing with events. I can't create a new event. I can only add a value to any one of these events. Okay? And if you get that concept, that's going to take you a long way in Altium Designer, because in the end, when you're trying to get access to the vias, right, or you're trying to get access to all the wires in the schematic editor, if you understand that you're trying to get access to that class of via, or you're trying to get either to the class itself to create one, or you're trying to get to the objects which represent them, then you're going to be able to say, okay, I want to extract out this information, or hey, I want to manipulate the particular via that's at this location. or I want them all the wires to be turned blue because I've collected all the objects that were wires, and now I want to send a property to them that says change your color property to blue instead of black. Right? So these are the kind of things that you can do, and as long as you get that concept, it'll make it a lot easier for you to code in Altium Designer. So let me jump back over here to our slide deck. All right. So I do need to give you some warnings. So if you've wetted your whistle for this, you're saying, okay, I'm kind of getting this thing. I see where he's going with this. This looks like it would be a lot of fun. Like spelunking in a cave, there's some warnings that you got to have, right? Because spelunking can be a dangerous thing when you're doing cave exploring. The same thing when you're getting into some of the coding here, or scripting coding here in Altium Designer. So first and foremost, Altium has been undergoing a code change. It used to be in Delphi. They're trying to move it over to C#. C# is basically Microsoft's version of C++. Okay? And I think, I'm only speculating on this, but I think Altium did that because obviously they're running on the Microsoft platform, right, which is the operating system, and they wanted something that's going to be very native to Microsoft. This coding has been going on since 2012. There's over 1 million lines of code. I remember having this conversation with one of my colleagues when I used to work at Altium. It was amazing back then. They may even be at 2 million lines of code. That's a lot of code that needs to be reviewed and changed, okay? And they decided they just couldn't do it all at once. They've been doing it piecemeal, which is why sometimes some of your functions, which seem like they worked just fine for years and under many versions, don't seem to work as the same way or same form anymore, and that's probably because of the code change that's been going on. As a result, what worked in one version may not work in another. And here's a really great example of this. This company called Desktop EDA. So Desktop EDA is a company we represent here, 9.Connects for North America. It's basically an intermediary tool that goes between Altium Designer and a mechanical tool like SolidWorks or Solid Edge. And what happens is that every single time that Altium or SolidWorks, for example, let's say we're going to do the one that goes between SolidWorks and Altium, every time they make a code change here, I guarantee you that Brian Watson of Desktop EDA has to reevaluate it and put out yet another executable to make sure that his code will work against these changes here. So that's how drastic some of these version changes can be. All right? It'd be nice if you could say, hey, look, for 80.15, that there's one change over here, but sometimes even some of those minor releases can change something to a point where he's got to go in, make a fix to it, and then send out a new executable to those who might be using it. The second thing is that Altium Designer does not make all of its functionality known. So I do know someone who got burned by this kind of recently. We felt really bad for him because there's nothing we could assist him with. It was not a project we were working on. And by the way, this individual is considered to be an expert in Altium scripting. So as a matter of fact, when we come to it here at 9.Connects, we ourselves do have an individual who is a scripting expert. His name's Jeff Condit. He's done webinars for us here in the past. But even then, Jeff takes such jobs, and we take these jobs here at 9.Connects, really treat them like hot potatoes. First and foremost, we would do them as time and material, and secondly, we would have to basically have a disclosure stating that we may not be able to finish the program because of these issues with the functionality. You may say, oh, this is a no-brainer, and logically in pseudocode it makes a lot of sense, and you come across something and it just won't provide the information we need, or Altium has not given us a way to access something that we need to see in there, and you just throw your hands up at that point. So when you're going to do this, there are some of those type of dangers. And then secondly, I'm not here to beat up on the support team. I was a former member of the support team. They work really hard, but the support team are not programmers. They are applications engineers, and they work on the GUI side of the interface, right? Their job is to help assist with primarily the schematics and the PCB tools, whether it's feature requests, bugs, or just general how-to type of things. As a matter of fact, in Altium, the one thing that always surprised me is that there is very little interaction between the support group and the coders. There's always been somewhat of a traditional firewall between them over there, and in fact, most of the Delphi examples that you see were really ones that were written by the coders themselves. So just keep in mind that the guys who are working the support team here are not coders, or if they do, they're hobbyists in it, and their primary job is to help customers through, let's say, the GUI interface side of things. All right, so therefore, just know that scripting in Altium Designer is not necessarily an easy thing to do. You really do have to have some experience in it, and even if you have experience in it, like I've had experience in it, you've got to understand this thing of this object-oriented programming. If you don't really get that concept of classes and objects and why they even bothered with it, you're just going to really struggle with it, because you're going to look at these examples and you're like, where did this come from? Is this something from Delphi? Is this something from Altium Designer? Why are they doing this format? You've got to really kind of build up from the foundation of understanding object-oriented programming to really look at those examples. You may have to find alternative ways of finding ways to do things. As I go back and remember, my colleague Jeff Conant was working on a project. This is before he joined us at 9.Connects a couple of years ago, and he was sweating bullets because there was one thing he was really working at that he couldn't, let's say, take the direct path in it, but he found a tricky way to get around it and was able to make it work. So just be aware that things that should be either exposed or things that should work may not work in it. And then also just be ready to explore on your own. The support from Altium is simply just going to be limited out there, but there's a lot of materials and resources. And that takes me really to my next point here. In terms of scripting examples, Altium Designer's got those. Here's the link to them here. There's also a tremendous number of other examples that have been made available, and this was brought to my attention by a good friend of mine, which isn't necessarily a friend, but is a good colleague of mine, Randy Clemens. Randy and I have had conversations in the past, and I apologize, Randy, if you're out there. I still need to get back to you on a couple of other things. But he is one of many contributors to these additional Altium scripting examples, and plus they also go into a little bit of a how-to tutorial on that site as well. So I did take a brief look at it, something to definitely take a look at in addition to downloading Altium's scripting examples as well. If you're interested in Delphi coding, I think the best site for keywords and references is one called Delphi Basics. It's out of the UK, and interestingly enough, if you just type in the keyword that you want to know more about, you type in Delphi in the Google search engine followed by that keyword, you'll find it on there. In fact, I think it's almost easier to use the Google search to find things on this website than to use the website itself at times. In terms of Delphi how-to videos, this fellow by the name of Gerhard, I stumbled upon these a couple of days ago, put out over 70 videos on how to work in Delphi. Okay, so if you want to take a look at that, that's really cool. And he did it specifically for high schoolers and college students, those people who just, they're not, let's say, not programming experts, but people who want to just learn how to use Delphi. And then lastly, if you want to learn a little bit more about object-oriented languages, there's some interesting videos by a fellow by the name of Daniel Schiffman. It's called The Coding Train. If you can get past his really corny introductory video, you'll find that he's very high energy and has a great enthusiasm for teaching these type of things to it. If you've got a few moments, I'd ask that you do the following. I'm going to put up a survey here, and we'll also show you the results as we're going along. We just like to find out whether this is something to be pursued or not. So we've got a couple of questions for you, and the survey will be popped up here in just a moment. And if you can just take a moment to fill those out, I would truly appreciate it. So for those who are taking off, thank you very much for joining us here today. And we'll see you next month. And just give you a little brief preview for next month. We are going to go back to our friend Sean Kelly. Sean is going to continue kind of with his talk about signal integrity. However, unlike the other two where we're talking more about the fundamentals of it, he's actually going to show us how to apply these things within the PCB tool itself. Thank you very much for your time, and we hope that you enjoyed this particular session.
Folks, I'm not sure why you showed up today, but we here at 9.Connects know that topics of this nature are important to you. We know they're important for designing the PCB, especially as speeds are increasing, signal integrity issues are becoming more and more prevalent, and the demand for wireless is growing bigger and bigger each day. At 9.Connects, this is the knowledge that we sell, and we sell it in different ways. Most of you know that we sell this knowledge in the form of trainings and coachings, especially with Altium Designer, and most recently with our new PCB Fundamentals class. We're also happy to announce that we have just released 2 one-day classes for Altium Designer libraries and schematics. In addition to coaching and training, we consult, and this word is really abused because anyone can call themselves consultants. So what do we mean by it? It means that if you have any challenges or issues with your PCB design, we can assist you. You have a board that will be handling large amounts of power? We can assist. Have boards that need compliance testing or designed to be compliant to a standard? We can assist. In short, we can assist you in achieving your design. And by the way, we're more than happy to assist in board layout as well. When I was doing design, we had challenges which we call technological hurdles, and I'm sure you deal with them all the time. And in some cases, you may be avoiding features like wireless or gigahertz speed devices because this stuff may seem like major technological hurdles to overcome. But you don't have to wing it or go at it alone or even avoid it. Let us here at 9.Connects get you over those technological hurdles. So for more information, contact us and check us out on the web at 9.connects.com. Thank you very much for taking a look at this video, and you have a wonderful day.